Welcome to Science with Ms. Steph. Today we are going to make a boat. Not your regular boat, but one made out of paper, and we're going to use beans to demonstrate buoyancy. Stay tuned. Hi, Ms. Steph here, and we're going to have some great fun today. We're going to learn a bit about buoyancy, or rather, we're going to demonstrate it. That's my objective. Sometimes it's just more instructive to show you than it is to tell you, right? And so that's what I love doing. That's one of my favorite things, is to show you what something is. All right, so today we're actually going to make a boat. Yes, I said it, a whole entire boat. Well, is it going to be fancy? Is it going to look like a boat? Maybe not. However, is it going to do what a boat technically does? Absolutely. So I just want to say thank you for joining me for Science with Ms. Steph. We are going to do our regular adventures, right? Our regular shenanigans, right? Don't we have a great time learning and having some science fun? What's buoyancy? Essentially, it's the floating force. So it involves water, it involves boats. So let's see it in action, right? Doesn't that sound like the best plan is to go ahead and see it in action? Right here, I have a bin. Today, for today's activity, you're going to need some type of large receptacle or something, right? Yeah, you'll need some paper. That's our boat making material. Okay, and you'll need some tape to keep your boat together. Like you see, I have kind of a pre-made little model over here. Y'all, I don't come on unless I at least kind of sort of try part of what I'm doing with y'all. All right, and then a bunch of water. Okay, a bunch of water. Now, remember last week we went on to Google, and so let's go on to Google again. Or whatever search engine you choose to use. All right. Ant, thanks for joining me. Little man, actually, you can try this with him. Okay, so just stick around for a second. Y'all can do this. So, what is buoyancy? The ability or tendency to float in water or air or some other fluid. Y'all didn't know that water and air are both fluids. Okay. But anyways, okay, not liquids, but they are both considered fluids when you talk about in the scientifically speaking. Okay. So how can metal float? Right? Because we know that things that are really heavy typically don't tend to float. But buoyancy, okay, and using that to our advantage helps things float. Okay, so let's pour some water, all right, into this container. And like I said, it's always easier to show you than to tell you about it, right? And it's frankly more fun. And yes, I have lots of water with me today. So this is a bit of a, for those of you interested in, kind of like the science of it and like, what are we talking about today? Yes, we're doing some fluid dynamics and all that type of stuff, but it all comes down to STEAM, right? Science, technology, engineering, arts, and mathematics. And so there's so many different ways that you can do this to make sure that we engage young minds, your minds, my mind, your mind, in the fun of it all, right? In science, technology, engineering, arts, and mathematics, right? So you can decorate this, you can do all that type of stuff. We'll talk about that another time. But the first thing that you want to do is make sure that you have lots and lots of water. Lots and lots of water. Okay? Not a little bit, a lot. Now let's do a couple of demonstrations before, or tests rather, before we go into trying to build something that will function as a boat and let our beans float, right? Because most of us know that beans don't float. Am I correct? You know that? You know that? Beans don't float. So today's engineering challenge is that we need to design something that will allow the beans to float. Right? Okay. So you see how we're designing a boat. All right. Now let's grab some beans here. These are the next materials that you need, right? I already told you need some type of bin. Okay. You need water. You need paper, some tape, and that's the paper and tape are your boat building materials. All right. And you need some beans. These are going to act like your people, the people that you're putting in your boat. Yeah, are beans. Okay. So if your boat sinks, you don't have to worry about anything happening to anyone, right? You're using these to test. All right. So let's find out. Do beans float? Maybe it's just that one. Twice. Seems pretty consistent. Let's go for a third round. Yeah, beans sink. Okay. That's what is going on with buoyancy. It's like the amount of water displaced and all that type of stuff. So what we're going to do is we're going to spread out the weight of the bean across a larger surface area. And then that should, using my science noggin, that should work, right? That should make my bean float, right? Now, yes, technically I am putting the bean inside of something, but it's mere technicality. All right. That's what we do every time we use a boat or get on a plane, right? We are displacing our mass, our weight, okay, across the sides, yes, of the vehicle that we're in, right? All right. So let's take this. Now, this is a one piece of paper. We're going to actually also do kind of a tester, right? Because we'll do some other testers, but just stick with me for now. I'm going to put this piece of paper here, and I'm going to fold this piece of paper. All right, I'll unfold it first, just so you can see what I did to it to create my boat-like situation. All right. Thank you so much for joining me. Hello and good afternoon, everyone. I'm Ms. Steph, and this is Science with Ms. Steph. All right. We do this every Saturday at 2:30 Eastern Standard, or well, these days, Eastern Daylight Savings Time. Okay. And we are hanging out today, and today I'm doing an activity that demonstrates, all right, buoyancy and the floating force and all those types of things. And we're going to have some fun engineering a boat. We're going to try to make something that will make it so that beans will float instead of sink, because I just demonstrated that they sink, right? In case you didn't know, I showed you. Okay. So we need to spread out the weight of the beans across a larger surface area. Okay. So simple, just piece of white paper, just piece of white paper, just piece of white paper. All right, so all I did was fold it in half. Okay. Now I need to make some sides, right? Because really I could just put it like this. Let me show you really quickly. I could just take it. I mean, I want to use that one, so that's why I'm not doing it. Okay. I could, right, just take this piece of paper and put it there. That floats. Great. Cool. But then if I try to put like beans on this, I don't know if that would really hold, right? Would that hold? Hmm, maybe. Hmm. Would it? Putting the beans there, right? There's a certain amount of, because this is more like a raft, right? This is kind of more raft versus boat. Okay. It's concept of a raft, right? And rafters are just flat. Okay. Now I'm just putting my beans here. How many beans, right? This is what we're looking at being engineers and testing things and all that type of stuff. How many beans can go in here? See, I'm just putting the all I'm not doing anything special. Oh, uh-oh. One of the beans fell off. Would that have happened if it had sides? I think not. All right. Another thing that's going on that makes sense, right, is that the paper is absorbing the water. So another material you could use for this activity would be foil, right? Would the foil be waterproof? I think so. All right, so anywho, that's one um one test. But like I said, we're making a boat. We're going to make a boat today. Also, I don't know if you can see on Facebook, but like my folded my folded piece of paper, like the half of the paper is actually like fallen. Okay. So I'm trying to be like really gentle with this, which I don't know why, but such is life. Okay. So you see how my whole apparatus is just falling apart. Okay. But I think that using a folded piece of paper is going to work out better. Okay. Once again, thank you for joining me. This is I'm Ms. Steph, and we're doing some science with Ms. Steph. Just rocking things out, right? We're getting a chance to observe um, buoyancy, our floating force, right? Because when we have um, pre-K kids, right? We do tests with them. Okay, do things. What floats, what doesn't float. But I'm telling you, my elder scientists, the older you get, right, the more you can do with these different concepts. Okay. So again, I'm just taking a piece of paper and I'm going to fold it. All right, let me come over here, make it so that you can actually see what I'm doing. I'm doing some pre-folds. Okay, so these are my sides. And then I'm doing like this. I'm folding in. And this is going to be like this. And I'm going to tape out. I'll do that another 3 times so that you can see it. Okay. And I'm making this very simple boat, right? So folding this corner in, or rather like this, or like that. That's what it looks like. That's what it looks like. And I'm taping it. While I'm doing this, does anyone have any questions on Facebook or Instagram? As I'm making my very simple boat. Okay, so there's different ways you can do it. You can do it so that it goes in like this, or you can do it so that it goes like that. Okay, you can just kind of make your crease in your crease however you want it. All right, tape so that it will stay. Going to go in. Right, so let me undo this one more time so that you can see it. Okay, right now the sides are out. I have my creases from the folds on both sides. And I'm going to pull this corner in, and it stands up a bit. And all I have to do is tape it. Right? So now I have a very simple rectangular based, okay, a rectangular based little boat. So as engineers, of course, we can think about whether or not this is the best shape. As far as the bottom of the boat, we could talk about that. You could try to fold your boat so that it was more like a square on the bottom and your sides were possibly taller, or maybe even you wanted to have something that looks more like the traditional boat bottom, where you have it pointing, maybe more pointy, something that's like almost like a triangle. There's different things that you could do, right? But today I'm just going for something basic. We only have a half hour, y'all. So, right? All right, so first of all, let's find out if my boat by itself will sink or float, because that's important. Because if the boat sinks, I mean, we don't want to put people in it, right? All right, so I'm going to put this in here, and it looks like it floats. Okay. Now, one of the things that's happening, of course, because it's paper, is that it's starting to absorb the water. All right. So that's why this is just kind of something that we do for short term. And remember how I said there are other materials that you could use. Those materials, of course, are harder to fold, but they are waterproof, right? And so there would be advantages to using them. Okay. So 1, 2, 3, 4. 5, 6, 7, 8. I'm just counting. 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, right? So I've already got 20 beans that are effectively floating. Why are they floating? Because they are inside a vessel that has been engineered by yours truly, right? To be able to float. Okay. And I'm just going to keep adding beans. Okay. We know that beans by themselves don't float because the amount of water that they displace weighs, okay, weighs more than um, the bean weighs more than the amount of water it displaces. Okay. That's how that works. And so I'm just adding more and more. Okay. And this is a pretty solid structure. Okay, as far as it being able to continue to float. So now over here on Facebook, y'all should be able to see what's happening. I've got some things structurally going on, but this boat is actually displacing very little water. Okay, I'm trying to wave at you. Okay, thank you for joining me. Okay, and so because it displaces so little water, that means that we're not going to get something that will sink. Okay? We're distributing all of our mass, our weight along the size of our little boat. Okay? So what else could we do with this? I already talked about how you could try using different materials. Okay? Because paper obviously after it sits in the water for long enough, the paper has already started to absorb the water. So there's going to be some issues, right, as far as long-term um, structural integrity is not there, right? Okay. Um, Also, even though the paper is easier to fold than, say, a piece of foil, a foil boat is going to be um, stronger. It will absorb the water. Um, it will absorb less water. Okay, or none at all. Now, the water will get in the kind of nooks and crannies, though. The other thing that you could do, you could try this with just a cup. right? Do cups sink or float? What do y'all think? I'm going to put this to the side, make this kind of slide over. There we go. Okay. Right? So my cup floats. So therefore, I could use my cup as a vessel. I wonder what the capacity is that the cup will be able to hold before it topples over or stops being able to hold my bean people. I like that, bean people. Okay. Or how much longer my paper boat will be able to hold its structural integrity, right? How long is my paper boat going to survive? See? So already my beans, they sank, right? Because with the cup, even though the cup floats, it tips over. So that's another thing that I was talking about with some of my students over the last couple of weeks. It's not just how you put things together when you're doing engineering and like thinking about like as an engineer, it's not just like how you put it together or the materials that you use. It's also then how you use that device, right? There's always devices come with instructions. And if you use the device wrong, it doesn't function properly, right? And so this situation just demonstrated that when I was putting the beans in, if I just throw the beans in really quickly, the mass of the beans tilted over. But if I were to make sure that I had beans on both sides so that there was balance, okay? Right? This is this idea of like how do you board the plane? How do you board a boat? How do you board and get off of a boat or a plane or a raft? All that types of stuff. So um this activity that we've done today really lets us learn about a lot of different concepts and lets us explore a lot of concepts, right? One of the things that I said earlier when I first came on today was it's a lot easier for you to see it and demonstrate it and try it than it is for me to explain. Okay. And so today we got a chance to see it. See, buoyancy in action, and displacement in action. Okay. And the importance of what materials you choose to use when doing your STEAM explorations. So I'm going to take everything, I'm going to take the things out so that you get an idea of what's going on inside of our bin. And I'll just very quickly review what we did today and tell you some different things that you might want to try at home when you're doing this. Okay, so cup first, easiest thing to take out. As you can see, some water got into my cup because of how I was loading my bean people. And yes, I like calling them bean people. The beans were my stand-in for people. Okay, seeing as our ocean was rather small, I feel like real people wouldn't probably fit in this ocean. And then let's take our boat out. As you can see, the boat, okay, absorbed water. Again, that was one of the reasons I said that you could try, if you had it at home, you could try other papers, other foldable materials. This works really well with foil because you can kind of do another demonstration where you fold up the foil, you ball up the foil, right, and put it into the water and see how a piece of foil balled up, okay, what that does. Spoiler alert, it sinks, okay? But if that same um, size piece of foil would be folded in a way that would be in boat form, okay, instead of balled up, it shifts how the water is displaced. It displaces the same amount of water, but it distributes and makes it a larger surface area that is being displaced. Okay, and so then you can put it in there and it would float. Okay, that piece of foil would float. And then you can try with your bean people, how many bean people would be able to fit inside of your boat before the boat sank. As you notice, our boat, even though look, you see how it has completely kind of disintegrated. Even though it had absorbed all that water, before I disturbed it, it was floating, and it floated for a while. Okay. The other part of this of STEAM that we could explore with this activity is the boat shape, exploring shapes, and art, and decorating the boats and all those types of things. And so there's a lot of different things that you can try when you are exploring buoyancy at home. So definitely make sure that you try this activity at home. Just as a quick recap, you need water. You need a lot of water. You could try this in the bathtub, I guess, if you wanted to, but really it's easier to control in this type of bin. You need something that's going to fill in for your people. I used beans. You could use paper clips if you want. You could use some type of paper clip. Okay. I wouldn't use anything bigger than that. I wouldn't try to use like markers or like um, rocks necessarily, just because um, as we know, rocks really are much more dense and larger than beans and so on and so forth. But beans, paper clips, those are um, things that I would suggest using after you have your water. And then, like I said, you could try and test. Um, Try different shapes of your base. My base was a rectangular shape. Okay, I had a rectangular base. I could somehow try to make a triangular base, a square base, some type of something that's closer to a circle base. How would that change how my paper boat would perform as far as being able to hold things and absorb water? And also different materials, right? What materials could I use instead of paper? Could I use foil? Would this work with wax paper? Hmm. Hmm. And what challenges would I find if I tried wax paper? Would this work with construction paper? Hmm. And what challenges would I find if I used construction paper? I say you try it and see what happens. Thank you for watching another episode of Science with Ms. Steph. Make sure that you like, share, and subscribe.